A very warm good morning to one and all present over here class. Welcome to the digital platform of APS. Now this is Pawan Kumar. Today I will start new chapter limits. So class, in previous lecture I have completed straight line and questions related to straight lines and all the formulas I have completed. Now class, in today lecture I will discuss some formulas related to limits. So let us start with the formula related to limits. So see, so first of all see the definition of limits. Definition of limits. So what is limit? Limits. First heading is limit. So the number a, consider the number a is said to be the limit of function. First of all, let fx be a function, then the number a is said to be limit of a function fx. The function fx is said to be, or the a number a is said to be limit of the function fx at x is equal to a. Function fx at x is equal to a. If for any arbitrary chosen positive number if for any arbitrary chosen positive number you can consider any value, that is k, positive number k, however small but not 0. However small but not 0. There exists a corresponding number L. There exists a corresponding number L. Consider that is greater than 0. We can consider greater than 0 such that fx, this is fx minus a is a number and its modulus will be less than k. See, this is the exact definition of limits. Now we are going to explain the left hand limit of function. The left hand limit of function. See, left hand limit of function. See, left hand limit of function. Suppose if x approaches to left or x approaches left to of the function, we can write x approaches a from left or from left. From left to the function. Consider from left to the function. Any value x approaches from left to the function, that is from smaller values. That is from smaller values of x, then a. You can consider here is a, because x approaches a from left. Then a is the limit of the function or limit of f or the limit of f or limit of fx, you can say, is known as left hand limit of the function. Left hand limit of function, and it can be written as it is written as limit x tends to minus a of fx is equal to limit h tends to 0 f of a minus x, a minus h, not a minus x. This is a minus h. Now right hand limit, similarly right hand limit of function you can suppose x approaches a from right, x approaches a from right, then if x approaches a from right, the function is from smaller to or larger to smaller. This is smaller values of x. Now this is from larger values of x. Larger values of x, then a, then a. the function or the limit of fx is known as right hand limit of function. Right hand limit of function, and it is also written as limit x tends to a plus limit x tends to a plus of fx is equal to limit h tends to 0 f of a plus h. This is the format to write the right hand limit. Now see, this is the left hand limit and the right hand limit, totally completed. Now see again, first of all you will consider any function fx, and x is approaches a from left to the function that is from smaller to or smaller values of x, that is from smaller values of x than a. Then the limit of fx, it is known as left hand limit of function, and it is also written as limit x tends to a minus of fx. This is read as limit x tends to a minus, and f of x is equal to limit h tends to 0 f of a minus h. Now this is if x approaches from a from right, and then the function is from larger values of x than a. X is larger values of a than a, or larger values of x than a. Then the limit of function fx is known as right hand limit of function, and it is also written as limit x tends to a plus of fx, h tends to 0 f of a plus h. Now left hand limit and right hand limit, this is the basic definition of left hand and right hand limit. See, now I will come to the existence of limit. See, my new heading is existence of limit. Heading is existence of limit. See, existence of limit. Condition for existence of limit: the left hand limit or let y is equal to fx be a function defined in given interval. the function fx is exist if or you can write the function fx is exist if the left hand limit of function at a given point will be equal to the right hand limit of function at a given point. At a given point, that is limit x tends to a minus of fx will be equal to limit x tends to a plus of fx. This is the condition for function to be exist. Left hand limit is equal to right hand limit. Now in case of suppose note point, when limit x tends to a minus x fx is not equal to limit x tends to a plus of fx, then you can write function does not exist. Function does not exist. Now see, means given function will be exist if the left hand limit of the function will be equal to the right hand limit of the function. You will calculate left hand limit of the given function and then right hand limit of the given function. If this will be equal, then function will be exist. If this is not equal, then function is not exist. See, when limit x tends to a minus f of x is not equal to the limit x tends to a plus f of x is not equal to right hand limit, then the function does not exist. And this is equal, then function exists. Now this topic is completed. Now I will come to the next topic or formulas. Some formulas related to limits. See, now heading is algebra of limits. Algebra of limits. Now first formula is consider let fx and gx be in two function defined in given interval, defined in given interval, then first part, limit x tends to a fx plus gx is equal to limit of the sum of two function is always equal to sum of the limits. Limit of the sum of two function is always equal to the sum of their limits. Now second is limit x tends to a fx minus gx, this is, or the limit of the difference of two function is always equal to difference of their limits. Now third is limit of the product of two function is always equal to product of their limits. This will be gx. See, now formula number 4 is limit x tends to a fx upon gx is equal to limit x tends to a of fx whole upon limit x tends to a of gx. See, this is the basic formula related to algebras. Of limit. Now see the fourth formula. The fourth formula is or fifth formula. Fourth formula is here. Fifth formula is limit x tends to a mod of fx. We can write limit x tends to a fx mod. Sixth formula, limit x tends to a fx to the whole power gx. We can write limit x tends to a fx to the whole power limit x tends to a gx. This is the formula number 6. Now formula number 7 is formula number 7. Formula number 7 is limit x tends to a k times fx. You can write k times limit x tends to a of fx. Now formula number 8 is limit x tends to a fx plus c is equal to limit x tends to a fx plus c. Now formula number 9, limit x tends to a k to the power fx, we can write k to the power limit x tends to a fx. This is the basic formula related to limits. Now all of you have to learn this formula. Now see, this all topics related to limit is completed.